Sample problem 4.4. The frame shown supports part of the roof of a small building. Knowing that the tension in the cable is 150, determine the reactions at the fixed end E. So knowing that our tension here, our cable exerts a force 150 kilonewtons, and say for example that one here, this is 150 kilonewtons, and it is said in the problem that the reaction at the fixed end E, here we have a fixed end. So if we have a fixed end here in two-dimensional, we have three reactions. The reactions are along the horizontal, we have also the vertical, and also the moment. So we have EX, EY, and our ME here. So looking also at the figure, the distance from point here going here, this is 2.25 plus 3.75, that is 6. And this distance at the top here, this is 4.5. Observing that this forms a right triangle, we can conclude that this hypotenuse here is just the distance from D to F, that is just equal to square root of 4.5 squared plus 6 squared. And that DF here is equal to 7.5 meters. Okay? Somehow our FBD would look like this one. So we have the reactions at our fixed support, EX, EY, and then the moment, ME. So now, having this FBD, we can apply our three equilibrium equations. So again, we have the sides of our triangle here as 4.5, and this one is 7.5. So we have here 7.5, and this one here is 4.5. Let's apply our three equilibrium equations. First, we have summation of forces along X is equal to 0. So we have positive towards that direction. So what are the forces along X? We have our EX and the component of our 150 force towards that direction. So we have the component of our 150. Ayan. So positive EX. And then we have also positive. How do we get the component of our 150 here? So basing on our right triangle here, if we have horizontal, the proportions of 150 relating to our cable here, that is, since this is horizontal, we have 4.5 over our hypotenuse 7.5 multiplied by our force 150 kilonewton. So is equal to 0. Therefore, solving this in our calculator, we have our EX equal to, we have negative 90 kilonewton. So having EX equal to negative 90 kilonewton, therefore, our assumption that EX is directed towards that direction, here, that direction, it should be the opposite. So instead of having EX directed towards that direction, we have our EX equal to 90 kilonewton directed towards the opposite direction. And this would be our answer. Okay? Now let's have summation of moments along Y. So summation of forces along Y, positive upwards, equal to 0. So what are the forces? So we have is 420 kilonewtons, this EY, and the component of 150 along Y. So this one here, they are all negative. So negative 420 kilonewtons. And then we have EY assumed to be directed upward. So we have positive EY. And then lastly, this one here. So since this is vertical, we choose the ratio vertical over hypotenuse. So we have here, we have negative, no? We have negative 6 over 7.5 of our force 150 kilonewton. That should be equal to 0. So solving in our calculator, our EY is equal to positive 200 kilonewtons. So since we have a positive answer, that means that our first assumption that EY is directed upwards is correct. It's upward. So this would be our answer. And then lastly, we have, since we already use summation of forces along x, along y, we have our summation of moments at a point where there are many unknown. Okay? So since we already have EX solved and EY solved, so the only unknown here is ME. So therefore, our pivot point should be located at E. Okay? So counterclockwise positive. So that should equal to 0. Okay? So what are the moments? So EX, it has no moment at point E, same as with EY. And what we have here, the component of our 150 kilonewton has no components because they are parallel here. It has no perpendicular distance. And the component of Y, this one here, it has a moment at point A, perpendicular. Okay, so we have, first we have 20 kilonewton. The moment arm is 1.8, the distance from here to here. And then it's positive. It tends to rotate counterclockwise. And then we have the second 20 kilonewton. We have 20 kilonewton times the moment arm, double the distance of 1.8. So we have 2 times 1.8 plus our third 20 kilonewton, triple the distance of 1.8. So we have 3 times 1.8. Then lastly, last 20 kilonewton times 4 times 1.8. And then we have also our component of 150 along the vertical, and it's counterclockwise, so it's negative 150 kilonewton multiplied by its moment arm, which is 4.5. And then lastly, our moment ME counterclockwise, meaning it's positive, so we have ME is equal to 0. So solving this expression here, our calculator, we have here ME is equal to 180 kilonewton dot meter. Since it's positive, it means that our assumption that it's counterclockwise is correct.